Atlas Roofing Corporation is pleased to present CrossVent RB. A radiant barrier is a great solution for blocking radiant heat. Your grandmother probably made use of these properties through kitchen physics. She covered the Thanksgiving turkey with a loose tent of aluminum foil before she put it in the oven. The foil reflected the oven's thermal radiation so that the meat cooked as evenly on top as on the bottom. She removed the foil briefly to let the skin brown, but when she took the bird from the oven, she tented it with foil again. Since aluminum doesn't emit much heat, the turkey stayed hot until the rest of the meal was ready. Cooking a turkey is a simple analogy, but the same principles of physics apply to an attic radiant barrier. Aluminum foil across the attic airspace reflects heat radiated by the roof. Even if the radiant barrier material has only one aluminum foil side, and that side faces down, it still stops downward heat transfer because the foil will not emit it and will not radiate the roof's heat to the insulation below it. A radiant barrier is a layer of aluminum foil placed in an airspace to block radiant heat transfer between a heat radiating surface, such as a hot roof, and a heat absorbing surface, such as conventional attic insulation. Aluminum foil is the operative material in radiant barriers. It has two physical properties of interest here. First, it reflects thermal radiation very well, and second, it emits or gives off very little heat. In other words, aluminum is a good heat reflector and a bad heat radiator. So where does Atlas fit in? Atlas presents to you CrossVent RB, a prefabricated ventilated insulation material with the added benefit of a radiant barrier. A radiant barrier system, or RBS, consists of a layer of aluminum foil placed in an airspace to block radiant heat transfer between the roof surface and the insulation below the airspace. An RBS depends on the surface property of low infrared emissivity to provide the performance benefit. Proper installation of radiant barriers is covered in design notes from Florida's Solar Energy Center and from ASTM standard C1158. From this pie chart, we can see attic heat flow is measured at around 22% of the total heat flow breakdown in a typical home. This pie chart refers specifically to homes, but the contribution of the roof in commercial buildings is similar, usually estimated as over 20%. Therefore, significant savings can be realized if heat flow from the roof into the interior can be blocked. The attics of homes in hot climates are low-heat Dutch ovens, costing millions in energy costs and reducing interior comfort. The same could be said of the airspace ventilating nail-based products. Ventilation itself only helps so much. The bottom line, protect your roof insulation from the intense radiant energy emitted from the roof deck with a radiant barrier system installed in the correct place. Keep the insulation cooler and you reduce the energy required for cooling as well as increasing your interior comfort. It can be seen that a quality radiant barrier system, such as CrossVent RB, can play a major role in reducing energy and increasing interior comfort. A radiant barrier is a highly reflective surface that emits poorly and changes the direction of infrared heat instead of having it absorbed into your insulation. Why let heat down into your building when you can change the direction with a low-cost, proven, high-performance radiant barrier as provided in CrossVent RB? The performance is unmatched and comfort and savings are immediate. Let's get technical for a moment. Reflectivity is the measure of how much heat is reflected, while emissivity is a measure of how much radiant heat is given off. An understanding of emissivity is necessary. Emissivity is the ability for an object to release or emit radiant heat. The lower the emissivity, the more difficult it is for heat to leave the surface in radiant form. Whatever amount of heat that is absorbed by the radiant barrier is not radiated through the airspace. Therefore, CrossVent RB insulation is protected from the heat of the roof. The difference in temperature between the interior and the surface of the insulation is therefore reduced, making the insulation more effective. If the surface of the insulation is 100 degrees instead of 150 degrees, it's easy to see how this would allow for greater thermal efficiency and require less HVAC operation. Let's take a quick look at what's happening on your roof. Without a radiant barrier, your roof radiates solar-generated heat through the OSB and the airspace in CrossVent RB, exposing the insulation board to extremely high temperatures. The insulation then absorbs some of the heat and gradually transfers it to the material it touches, principally the roof deck or ceiling. This heat transfer makes your air conditioner run longer and consumes more electricity. With CrossVent RB, an aluminum foil radiant barrier blocks approximately 95% of the heat radiated down by the roof, so it can reach the insulation in CrossVent RB. In summer, when your roof gets very hot, a radiant barrier cuts air conditioning costs by blocking a sizable portion of the downward heat gain into the building. In the warm spring and fall, radiant barriers may save even more energy and cooling dollars by increasing your personal comfort. During these milder seasons, outdoor air temperatures are comfortable much of the time. Yet, solar energy still heats up your roof. Insulation, roof deck, and ceiling temperatures can rise to make you uncomfortably warm. A radiant barrier stops almost all of this downward heat transfer so that you can stay comfortable without air conditioning during mild weather. The temperature graph here shows an attic airspace prior to installing a radiant barrier. The area on the right shows the same attic airspace for a radiant barrier before a radiant barrier was installed. As you can see, the temperature peaked at the end of May at 130 degrees. With a radiant barrier in place, it peaked at 111 degrees in mid-June, a reduction of 19 degrees. Imagine your home if this temperature drop occurred and the difference in your heating bills. Single-sided radiant barrier material should be installed with the foil side facing down, such as in the case with CrossVent RB. This may run counter to our intuitive feeling of how things work, but it does work, and it works well. Radiant barriers must also have an airspace. To understand how it works, remember two properties of aluminum foil. From our Thanksgiving turkey analogy, we remember that foil reflects radiant heat very well, but does not radiate heat well. It does not emit heat to the other surfaces around it, namely the polyiso insulation used on CrossVent RB. The foil must have an airspace again, and if it touches anything, it will then transfer heat through conductive heat transfer. Therefore, it cannot touch another surface. From this graph, we can see the optimal place for a radiant barrier. Just think of the airspace of CrossVent RB as the attic space. The foil must face downward toward the airspace, just as a radiant barrier works best when it is placed at the roof deck facing the open space of the attic. The least desirable place for the radiant barrier is the floor of the attic because dirt, dust, and other accumulation retards its effectiveness. So where does ACFoam CrossVent RB go? ACFoam CrossVent panels are installed above the deck under the shingles, the perfect place to prevent heat penetration. Installation of CrossVent RB is a cinch. Panels are easy to handle, fasten directly to the deck, and come in convenient 4-foot by 8-foot pieces. Installation of Atlas nailable insulation is fast and easy. Atlas does require the use of Atlas nail-based fasteners. Savings from a radiant barrier depend on the amount of heat the roof and airspace contribute to the building's cooling load. Cooling load is the total amount of heat your air conditioner must remove to maintain comfortable indoor temperatures. In general, the more energy efficient the rest of the building is, the larger the percentage of energy you save from an attic radiant barrier, because the roof makes up a larger portion of the cooling load. Just remember that a radiant barrier can save about 8 to 20% on your air conditioning costs in the southeast. Any Sunbelt building owner knows that an 8 to 20% savings on air conditioning bills can be significant. These savings vary by location, R values, and other factors. Informal surveys show a wide range of material costs and installation costs. Note that no additional labor is required to install the radiant barrier in CrossVent RB. You can expect a payback of 6 to 10 years. The Florida Solar Energy Center has measured the temperature of roof shingles above radiant barriers on hot, sunny summer days. Depending on the color of the shingles, their peak temperatures are only 2 to 5 degrees higher than the temperature of shingles under the same conditions without a radiant barrier. Roofing materials are manufactured to withstand the high temperatures to which they are frequently exposed. A 2 to 5 degree increase in peak temperatures for shingles that often reach 160 to 190 degrees should not have any adverse effect. Because temperature changes are very small, shingle warranties should not be subject to cancellation by the manufacturer on the basis of radiant barrier installation. Several manufacturers have already announced approval of installation of shingles over radiant barrier roof decks. However, it may be wise to review the warranty to be sure that the nature will not void it. You may want to inquire directly of the manufacturer. Any changes in warranty should be substantiated in writing. Atlas manufactures asphalt roofing shingles and accepts radiant barriers under the terms of the Atlas Limited Warranty. Atlas also allows homeowners to use CrossVent RB as a qualifying component of the Atlas Signature Select roofing system. For more information, visit www.selectyourroof.com. Radiant barriers are an inexpensive but effective way for building owners to save energy and money. While they are not a new concept, radiant barriers have only recently been proved effective for energy conservation. As we've seen, CrossVent RB saves money and pays for itself in just a few years. It's a passive measure. It doesn't require any change of behavior of the occupant or improvements in HVAC equipment efficiency. CrossVent RB adds another level of thermal performance to the excellent thermal performance already provided by CrossVent. Estimated savings between 8 and 20% will vary depending on specific conditions, as we've shown. Just remember, CrossVent RB is the only polyiso insulation that provides unsurpassed thermal efficiency. A perforated, breathable, low emissivity foil radiant barrier securely bonded to OSB, a radiant barrier panel that reflects up to 97% of the sun's radiant energy, an additional 7 to 10% savings annually on cooling costs, a 20-year thermal limited warranty, and only CrossVent RB substantially limits conductive and radiant heat transfer. If you want to see ACFoam, CrossVent RB, and other Atlas products in action, please visit us at www.atlasroofing.com/AtlasCity.